Intensive property. An intensive property is a characteristic or property of a substance that does not depend on the amount or size of the sample being measured. In other words, intensive properties remain constant regardless of the quantity of the substance being measured. Examples of intensive properties include temperature, density, melting point, boiling point, refractive index, specific heat capacity, and conductivity. These properties are used to identify and characterize different substances and are often used in scientific experiments and analyses. Intensive properties can be used to distinguish between different substances, as each substance has a unique set of intensive properties. For example, water has a density of 1 gram per cc at room temperature and pressure, regardless of the amount of water being measured. Similarly, the melting point of gold is 1064 degrees Celsius, regardless of the amount of gold being measured. Intensive properties are important in many fields of science, including chemistry, physics, and material science. They provide a means of describing and identifying substances, and can be used to predict the behavior and properties of materials under different conditions. Extensive property. An extensive property is a characteristic or property of a substance that depends on the amount or size of the sample being measured. In other words, extensive properties increase or decrease in proportion to the amount or size of the substance being measured. Examples of extensive properties include mass, volume, length, energy, and momentum. These properties are often used to describe and measure the quantity of a substance or system. For example, the mass of a block of iron increases with the size of the block, and the volume of a gas increases with the amount of gas present. Similarly, the energy of a system is directly proportional to the amount of matter in the system. Extensive properties can be used to compare and measure different samples of the same substance, and can also be used to determine the mass or volume of a substance. They are often used in engineering, physics, and chemistry to describe and analyze systems and processes. It is important to note that extensive properties are related to the quantity of matter being measured, whereas intensive properties are not. Chemical change. Chemical change, also known as a chemical reaction, refers to the process in which one or more substances are transformed into new substances with different chemical and physical properties. During a chemical change, chemical bonds are broken and new bonds are formed, resulting in the creation of a new chemical composition. Examples of chemical changes include the combustion of wood, the rusting of iron, the reaction of an acid with a base to form salt and water, and the decomposition of organic matter. Chemical changes are typically accompanied by changes in temperature, the release or absorption of energy, the production of gases or solids, and/or a change in color. Chemical changes are different from physical changes, which involve a change in the physical state or appearance of a substance, but not a change in its chemical composition. Examples of physical changes include melting ice, boiling water, and dissolving salt in water. Physical change. A physical change is a process that does not result in the formation of new chemical substances. Instead, physical changes alter the physical state or appearance of a substance, without changing its chemical composition. Physical changes can be reversed or undone. Examples of physical changes include melting ice, boiling water, cutting paper, grinding coffee beans, and crushing a can. In each of these cases, the substance undergoes a change in its physical appearance or state, but the chemical composition remains the same. Physical changes can involve changes in the state of matter, solid, liquid, or gas, changes in the size or shape of an object, changes in texture or appearance, and changes in density or volume. Physical changes can also involve changes in temperature, pressure, or the presence of a magnetic or electric field. It is important to note that physical changes do not involve the breaking or forming of chemical bonds, which is characteristic of a chemical change.